Welcome to homework.
Here the question is, use principles of atomic structure to answer each of the following. First one is, the radius of calcium atom is 197 pm, it is picometer. The radius of calcium 2 plus is 99 picometer. Account for the difference. So in case of calcium, here for the answer, A, calcium is atomic number 20. That means the electronic configuration is 28A2. Outermost orbit, fourth one, and having 2 electrons. Whereas in case of calcium 2 plus, electronic configuration is 288. Now just by looking at the electronic configuration, you can understand why the radius of calcium 2 plus is less. First thing is, when 2 electrons are removed, fourth shell is no more in case of calcium 2 plus, and that is why it is smaller in size. Radius is less. Second is, in case of calcium atom, 20 electrons and 20 protons are present. 20 protons at the center with 20 electrons around it, around the nucleus. Whereas in case of calcium 2 plus, 20 protons of nucleus attracting only 18 electrons. So naturally, force of attraction towards the nucleus will be stronger in case of calcium 2 plus as compared to calcium atom, and that is why the size is smaller in calcium 2 plus as compared to calcium atom. Now in case of B, what happens? B question is, the lattice energy of calcium oxide solid is minus 3460 kilojoules per mole. The lattice energy of K2O is minus 2240 kilojoules per mole. Account for the difference. Lattice energy is the energy which is coming out when cation and anions are coming together and forming the lattice. So if the energy which is coming out is more, that means the lattice is stronger and the force of attraction between cation and anion, that is electrostatic force of attraction, is stronger. Now this force of attraction depends upon the charge over the cation and anion. In both the case, the anion is same, that is oxygen, whereas the cation is different. So just we have to see where the force of attraction will be stronger in case of cation. In case of calcium ion, and potassium ion, potassium plus and calcium 2 plus. So in case of calcium ion, the force of attraction is stronger because the size is small and charge is more. Here potassium is bigger in size and having unit positive charge, just 1. So naturally, force of attraction, here the charge density is more. Density is more. What is charge density? It is the charge per unit area. So if size is small and charge is more, naturally charge per unit area will be more in case of calcium as compared to potassium. So force of attraction between oxygen and calcium will be stronger as compared to force of attraction between potassium and oxygen. Now come to C. Given the ionization values and explain the difference between calcium and potassium with regard to their first and second ionization energies. Now here again we are considering the size, and after that that will depend upon the electronic configuration. So first one is potassium. First is potassium and atomic number is 19. So electronic configuration will be 2881. Whereas in case of calcium, where the atomic number is 20, it is 2882. So when potassium one electron is removed, that is the first ionization energy, then removal of first electron is easier in case of potassium as compared to calcium, because after the removal of one electron, it is getting the stable configuration, that is octet is complete. And that is why the potassium will have this tendency to remove one electron and get this stable structure. That can be the first reason. Whereas even after the removal of first electron, in case of calcium, it is not getting the stable structure. That is, it is having the structure 2881, which is octet is not complete, so it is having less tendency to remove the electron. Second is size of potassium is bigger as compared to size of calcium. So removal of electron from the calcium is much more difficult as compared to removal of electron from the bigger size, because it is less attracted by the nucleus, it is far from the nucleus, and removal is easier. That is why less ionization energy in case of potassium as compared to calcium. When it is the question of the second ionization energy, then second electron we are trying to remove from the complete octet, that is the stable configuration, that is much more difficult as compared to uh, as in case of calcium 2 plus, it is much more difficult, and that is why second ionization energy of potassium should be more as compared to calcium. Whereas here in calcium you are removing the electron, second electron, from the fourth shell, that is outer shell, and that is far from the nucleus, and it is less attracted by the nucleus, and by the removal of this, your octet is complete. That is why removal of second electron from the calcium plus 1 is much easier, so its second ionization energy is less. So ionization energy for the second ionization energy is less as compared to second ionization energy of potassium. In case of calcium, it is less. Now come to D. D is first ionization energy of magnesium is 738 kilojoules per mole, and that of aluminum is 578 kilojoules per mole. Account for the difference. Now here again we have to see the electronic configuration first. Magnesium is 12. So its electronic configuration is 1s2, 2s2, 2p6, 3s2. Whereas in case of aluminium, which is atomic number 13, electronic configuration is 1s2, 2s2, 2p6, 3s1. So here the question is, the magnesium is having more first ionization energy as compared to aluminium. So aluminium, from the aluminium removal is much easier, and that you can understand that in case of aluminium it is easier because you are removing the electron from the it's actually electronic configuration, it's 3s2 and after that 3p1. So this last electron from the p orbital you are removing, that is much easier than the removal of one electron from the magnesium, because here you have to remove the electron from the 3s orbital, which are paired electrons, and from that you are trying to remove the electron. That is much more difficult, and that is why here the first ionization energy of magnesium is more as compared to aluminium.